Ploidy refers to the number of set of homologous chromosomes in a cell or an organism, and having multiple set of chromosomes is known as polyploidy. Ploidies can be of two types, euploidy and aneuploidy. Euploidy is a condition when a cell or an organism has more than one complete set of chromosomes. So, for example, humans have 23 pairs of chromosomes. That is, 23 we get from the mother and 23 from the father. Hence, it is represented as 2n. So, it is 2 into 23, we get 46. And hence, we are known as diploid. But suppose, say, if we have 69 chromosomes, so no more we are 2n. Now we become 3n, that is triploid. That is 3 into 23 will lead to 69 chromosomes. And you know that no animals will be having such a condition except plants. So uniploidy can be of monoploid, diploid, or polyploid. Polyploidy is again classified as autopolyploidy and allopolyploidy. We shall study about these in the next section. Aniploidy. However, if one or more chromosomes, not the set, are missing, the cell is considered or called as aniploidy. For example, we have 23 pair of chromosome, but now we are not talking about here the set of chromosome. Here we are talking about the individual chromosome. Suppose say the chromosome 21. There you know that we have a homologous or a pair of homologous chromosomes. But suppose say the 21 chromosome is having one extra chromosome, then it becomes trisomy. So it is affecting only that 21 chromosome and not a 23 chromosome. So hope the definition is clear. In euploidy, we are referring to the entire set of chromosome. However, in aneuploidy, we refer to one or more chromosomes that are missing or an extra is added. So aneuploidy is of two types, hyperpolyploidy and hyperpolyploidy. Hyperpolyploidy, if you consider in diploid organism, it is 2n minus 1. That is, such individual will be a monosomy. Suppose if both the 2n are deleted, we end up in nullisomy. So it can also be, aneuploidy can also be addition. For example, 2n plus 1. So we have an extra chromosome. So it is trisomy. Similarly, 2n plus 2 tetrasomy. Any variation from diploid is not tolerated in higher animals. However, in plants, ploidy is well tolerated as it leads to extraordinary features in plant which are economically important. So these are some of the example. You can see the first picture which shows the diploid, that is 2n, followed by monoploidy, that is they have only one set of chromosome, and then polyploidy, that is they have more than normal number of sets of chromosome, that is triploid and tetraploid. So these are some of the example of euploidy. So as I said earlier, The triploids or euploidy are usually valuable in plants because whatever we see the new generation plant, that is whether a seedless banana or watermelon or orange or grapes, is a typical example for euploidies or triploids. Coming to the definition of autopolyploidy, auto, the very word tells it is self, and polyploidy means we are having multiple set. In the first picture, if you see, it is species A, which is a diploid. So this is the diploid chromosome. So if there is a chromosomal doubling here, we get tetraploid. That is, these two chromosomes have duplicated and also these two chromosomes have duplicated. Hence, we end up in a tetraploid. That is 1, 2, 3, 4. And why it is called auto means because it only one species was involved and no other species. So one species of diploid was doubled and we ended up in tetraploidy. If we look at alloploidy, the very word allo tells that they are different. So we involve two species, species A and species B, both are diploid. For easy understanding, there is a color difference between these two species. So when these species are hybridized, what we get is again a tetraploid. But here you can see the difference. This is the blue, the dark blue is the chromosome from the species A, and here it is the species B, and this dark brown is of the species A, and the light brown is that of the species B. So this is also a tetraploid, but this tetraploid has not come from one species, but instead it has come from the two different species, that is species A diploid and species B diploid. Hence it is called as allotetraploid. This picture also signifies the same. Another terminology is amphipolyploidy. Here you can see that we have species 1 and species 2, that is A and B. When they cross, these are the following gametes which are formed: A1, A2, and A3, and here B1 and B2. When they are fertilized, the new offspring, what we get is AB, but it is a sterile hybrid because there is a missing pair of chromosome. So that is why it is sterile. So under these conditions, what we require is the doubling of the chromosome, which can be done by the chemical method or radiation method. The most commonly used chemical is the colchicine. So doubling the chromosome number in a sterile hybrid can often produce a fertile hybrid, and this process is known as amphipolyploidy. So here we cause the chromosome doubling. Now you can see that each of the chromosome has their respective pairs. Please note the difference between these two. Earlier there was a missing pair, but now each one has a pair. So this is AA and BB. So these are fertile amphidiploid, and this is their respective gametes formation. So do remember, amphipolyploidy means whenever there is a sterile condition, we can induce chromosome doubling to make it a fertile hybrid. Some of the best examples of these allopolyploidy are the domesticated cotton. The wild type cotton, you can see the difference of the fiber or the yarn and the size. But in domesticated, we can see all these qualities which are better. So, whatever we have, the New World cotton is known as Gospium hirsutum. So, this is obtained by crossing Old World cotton with American upland cotton. So, these have small chromosome while the later has the large chromosome. And how we got this 26 chromosome is that is there are 13 small chromosome and 13 large chromosome, which is nothing but 26. So this is a variety wherein we can go for a chromosome doubling. When we go for a chromosome doubling of this, we get a new variety which is known as Gospium hirsutum, which is grown 90% across globally. And this has 52 chromosomes. That is, you can have here, we already have 26, so 2 into 26 is 52. Hence, this was univalent. Now we have the bivalent. Similarly, in the wheat, you can see that Triticum sativum is the best variety which is now available. How this was obtained? This was obtained by allopolyploidy, that is, crossing over two different species which are represented as AA and BB. So this is having 14 chromosomes each. So when they cross, we got AABB, which is in total having 28 chromosomes. That is 2 into 14, which leads to 28 chromosomes. And this species in turn was crossed with another variety of wheat, which is represented as DD. So now finally we end up with a new variety which is known as Triticum sativum, which is having AABBDD. That is totally it has 42 chromosome. That is 28 plus 14, it leads to 42. So this is the common bread wheat. It is an allohexaploidy. Allo means because we are using different types of species, and why it is known as hexaploid means here one, 2, 3, 4, 5, 6, and hence it is known as hexa 6, and ploidy is more in number.